Welcome, ladies and gentlemen. Today we're going to talk about graphing piecewise functions. So you're going to need your notes. We're actually going to be graphing, so you're going to need graph paper, pencil, and a calculator, please. Right. Our learning target objective is that when we are given a piecewise equation, you are going to be able to graph those functions. Now, what is a piecewise function? We've talked about this before. We're just going to repeat ourselves a little bit. A piecewise function is made up of pieces of different functions which are a result of their different domains. That's going to be really important when we're graphing. Our x values are going to determine where our graph is going to go and how far our graph will go. These are not inequalities. That's really important. There will be no shading, no dashed lines, right? They are simply pieces of different graphs. And just a little reminder, we read f of x. That's how you read this, f of x. And it means the same thing as y. So here's example number 1. We're going to graph this piecewise function. We're given two different equations. Both equations are lines. So when we set this up, we're going to do this first one right here. We have our x and we have our y. Now, when we set up our table, this is what we're going to be looking at. X is less than 3. That means we're going to start our table at 3 and we're going to get smaller. So 2 and then 1. It's really important that we notice that it's just less than. So this is going to be an open circle on this one. All right? Once we figure out our x values, we're going to plug those in to find our y. So I'm going to take 1 times 3 minus 4, which is going to give me a negative 1. And then I'll take 1 times 2 minus 4, which gives me a negative 2. And then 1 times 1 minus 4, which will give me a negative 3. Once I have this all together, now I can graph. When I'm graphing this, I'm going to start at 3, negative 1. It's really important that I have this here. It's going to be an open circle. So I'm going to go to 3, negative 1, draw an open circle there. Okay, because it doesn't include 3, it just goes up to 3. The next one is 2, negative 2, 1, negative 3, and since it says it's just less than 3, it's going to continue on forever, so I need to put an arrow on that. There's our first function that's graphed. Now we're going to move on to our second function. So we have our x and our y. Now our restriction is that x is greater than or equal to 3. So we're going to start at 3 and then we're going to get greater. So we'll use 4 and 5. Now it's also equal to, so this is going to be a closed point when we graph it. Now we're just going to plug it in. So I'm going to have 2 times 3 plus 1. So I get 7. 2 times 4 plus 1, which would be 9, and 2 times 5 plus 1, which is 11. Now I can go ahead and I can graph this. I'm going to start at 3, 7, and it's going to be a closed circle because I have that closed right there. So 3, 7 is closed, and then I have 4, 9, and then I would have 6, 11, and I'm going to start this, and it's going to go forever in that direction. So I'm stopping here with my closed circle. All right, there's example number 1. Make sure you get all of this in your notes. We have 2 more examples that also need to be written in your notes, please. All right, here's example number 2. We have 2 different equations again that we have to graph. But on this first one, if you guys notice, it's going to be an absolute value equation. So we're going to make a V. We're going to set it up the same way. We have our x and our y. Our x, if we look here, it says our x has to be less than 5. So we're going to go 5, 4, 3. Now at 5, it's an open circle. That's really important for us to remember and know when we graph. But since it's an absolute value, it's really important to know where our vertex is, so where our v is going to be. Our vertex, remember, it's going to be opposite of what's in here, so it's going to be 3, and then whatever out here, there's nothing, so 3, 0. So on my table here, I have 3, 0. I need to go at least 1 after my vertex. That's very important. So I have to go into 2, at least. Now when I plug this in, I'm going to plug in 5. So I have absolute value of 5 minus 3, which is the absolute value of 2, which is equals 2. Absolute value of 4 minus 3, which equals absolute value of 1, which equals 1. We know 3, 0 because that's our vertex. And then we'll go over to 2. So 2 minus 3 equals absolute value of negative 1. But the absolute value means it has to come out positive. So we're going to have a 1 there. Once we have our table filled out, now we can graph. I'm going to go start with 5, 2. At 5, 2 is going to be an open circle. That's really important. Everything after it's going to be closed, but that's going to be open. Then I have 4, 1, 3, 0, and it's really important. This is where my absolute value comes in handy, because then I'm going to have 2, 1. This is what this graph should look like, and it's going to go on forever in the other direction, so I have to put that arrow there. All right, our next one is just a line. So we're going to look at our restriction. We know that x has to be greater than or equal to 5. So when we set this up, it's going to be 5, 6, 7. 3 is plenty when we're just talking about lines. It's going to be closed here because it's greater than or equal to, so 5 is included. Now we can just plug it in. We have 1/2 times 5 minus 2, which equals 1/2, or if you want to think it as 0.5, that's fine. Then 1/2 times 6 minus 2, which equals 1. 1/2 times 7 minus 2 equals 1.5, or 1.5. Now when we graph this one at 5 and 0.5, so 5.5, it's going to be a closed circle. Then we're going to go 6, 1, then 7 and 1.5. And then we're going to put our arrow at the end because it's going forever in that other direction. So the main key is make sure that we have our open and closed circles where we're supposed to be. All right, there's example number 2. Last example that we need to get into our notes, ladies and gentlemen. We are going to graph 3 this time. So our first one right here is just y equals 3. So I have my x and my y. Here are my restrictions though. I go from 0 to 2. So 0, 1, 2. At 0, you notice it's just less than, so I'm going to have an open circle. At 2, it's going to be a closed circle. So if I fill this in, all of my y values are going to be the same because it's just 3. So 3, 3, 3. Now when I graph this one, I'm going to go to 0, 3. Has to be an open circle. Then 1, 3, and 2, 3. 2, 3, it's closed. So there's my line. On my next one, my x and my y, my restrictions are between 2 and 4. So I have 2, 3, 4. At 2, it's just less than, so it's going to be open. At 4, it's less than or equal to, so it's going to be closed. My equation is just y equals 1, so all my y's are 1. When I graph this, I'm going to go 2, 1, and it's going to be an open circle. Then 3, 1, and then 4, 1 is closed. So there's my line there. And last but not least, my last equation, y equals 5. I have a restriction from 4 to 6. So it's going to be 4, 5, 6. 4 is just less than, so it's open. 6 is less than or equal to, so it's going to be a closed circle there. Y just equals 5. So all of these are going to be 5. So here I go. 4, 5, open circle. 5, 5. And then 6, 5 is going to be a closed circle. There are my 3 equations. Now, just a little side note, ladies and gentlemen. This is called the step function because they look like steps. So make sure you get that written down too. All right, as long as you have all 3 examples written down, that's all that I have for you today. I hope you go out and enjoy this wonderful day, and I will be seeing you later. Bye.